A few more examples on finding adjoint of matrices. In these examples, we'll be finding the adjoint of 2 by 2 matrices. The first one, A. Let me write my solution. The first question here says we should find the adjoint of the matrix A, which is equal to, which has the elements 1, 3, 4, 2. We do the same thing. First, recall that adjoint of A is equal to the transpose. Recall that the adjoint of A is equal to the transpose of the matrix of cofactors of A. The adjoint of A is the transpose of the matrix of cofactors of A. So let M be the matrix of cofactors of A. The matrix M will contain the cofactor of these elements and all of these too. So C11 is the cofactor of the element in the first row, first column, which is this element. Let's find the cofactor of 1. To find the cofactor of 1, cross the row and column that, cross the row and column where 1 is located. First of all, before I go on to that, let me write their signs. The signs of the cofactor should be plus, minus, minus, plus. So that means I have 2 left, and I'm going to give plus to 2. That gives me 2. The cofactor of this element 1 is what? 2. Take note of this. Let's find the cofactor of the second element. Let's find the cofactor of the second element. That means I want to find the cofactor of what? Of these 3. Hold on, let me try and clean those lines I've drawn. The cofactor of this element 1, its cofactor will be gotten by crossing its row and column. I have 2 left, and 2 should take a what? 2 should take its cofactor should take a positive sign. Plus, minus, minus, plus. That gives me plus times 2, which is plus 2. So let me go ahead now and find the cofactor of the second element, which is in the first row, second column. This is the element in the first row, second column. To find the cofactor of 3, all I have to do is cross the row and column that contain 3. Cross the row and column that 3 belongs to. What do I have left? I will have 4 left. That 4 should take a negative sign. So that's minus times 4, which is what? Minus 4. Let's go ahead and find the cofactor of what? Of 4. Minus times 4, which is minus 4. Let's go ahead and find the cofactor of 4. 4 is in the second row, first column. 4 is in the second row, first column. So it should be given, its cofactor should be given a negative sign. Let me scroll back up. When I cross the row and column containing 4, if I cross the row and column containing 4, I'll have 3 left. 3 should take a negative sign. That gives me what? That gives me minus times 3, which is what? Minus 3. Now, I'll go ahead and find the cofactor of the last element, which is what? 2. The cofactor of 2, to get it, I'll cross the row and column containing 2. I'll have 1 left. The cofactor of 2 should take a positive sign. So, plus times 1. The 1 I have left is my cofactor. So, that means what? The cofactor of the element in the second row, second column is plus times 1, which is what? Plus 1. So my matrix of cofactors now will be, as you can see, 2 minus 4 minus 3, 1. This is my matrix of cofactors. You understand? Of A. After getting the matrix of cofactors, the adjoint of A will be the transpose of this matrix of cofactors of A. So the adjoint of A will be 2 minus 4 minus 3 what? 1. So I just change the first row to the first column, and I'll change the second row to the second column. That's what that gives me my adjoint. So the adjoint of matrix A, the adjoint of matrix A is what? 2 minus 3. Let me space that more. 2 minus 3 minus 4, 1. So that gives you what the question requires. That's the adjoint of A. Now notice that there's a pattern here. If I could, take you back a bit. A is what? Matrix A is what? What's matrix A? Let me go back and check. Matrix A is 1, 3, 4, 2. Matrix A is what? 1, 3, 4, 2. But the adjoint of matrix A is what? The adjoint of matrix A is 2 minus 3 minus 4, 1. So technically speaking, you will notice that all that you require to find the adjoint of a 2 by 2 matrix, you'll notice all that is required is adjoint of A is what? If A is A, B, C, D, all that is required, if A is what? A, B, C, D. Let me put it this way. Therefore, if A is the matrix what? If A is the matrix A, B, C, D, it means, therefore, that the adjoint of A is the matrix. It therefore means that the adjoint of A will be the matrix what? You will notice that all that we have done is just to bring 2 and put it in the place of 1, swap 2 and 1. You understand? It's just to exchange the elements in this diagonal. Bring 2 to the position of 1 and take 1 to the position of 2. Exchange these elements and multiply what? And multiply the elements in the second diagonal by minus 1. That's all that gives us our adjoint. So that means we just did adjoint of A. If A is A, B, C, D, the adjoint of A. If A is A, B, C, D here, the adjoint of A will just be D, A minus B minus C. So technically speaking, that's what gives us our adjoint. Just swap A and D and multiply, B and C by minus 1. That's all. Let's take another example. Let's take a second example. Number 2. B1452. B matrix B is what? 1, 4, 5, 2. So first, let me find M, which is the matrix of cofactors of B. The matrix of cofactors will contain cofactor of the element in the first row, first column, C11. That of the element in the what? First row, second column, C12. That of the element in the second row, first column, C21. And that of the element in the what? And that of the element in the second row, second column, C22. So let's find C11. To get C11, very easy. I'll just cross that element. This is the element in the first row, first column 1. Its cofactor will be what? Its cofactor will be, don't forget, the signs are plus, minus, minus, plus. So its cofactor will be plus times 2. Plus, minus, minus, plus. That means its cofactor will be what? Plus times 2. And that gives me plus 2. Let's find the cofactor of the element in the first row, second column. The cofactor of the element in the what? First row, second column. That's the cofactor of 4. All I need to do is simple. Cross 4. What do I have left? 5. 5 should take a negative sign. So the cofactor of 4 is what? The cofactor of 4 is minus times 5. So that gives me what? Minus 5. Let's find the cofactor of the element in the second row, first column. What's the element in the second row, first column? This one. Second row, first column. That means you are looking for the cofactor of 5. After crossing the row and column where 5 is located, all I have left is what? 4. 4 should take a negative sign. So the cofactor of 5 is what? Minus 4. The cofactor of 5 is minus times 4. Minus 4. Let's go ahead and find the cofactor of the element in the second row, second column. The element in the second row, second column is 2. Second row, second column. Second row, second column. This is the element in that position. All I have left after crossing its row and column is 1. 1 should take a positive sign. So I'll get what? 1 times. I'll get 1 times plus or plus times 1. And that gives me 1. So that means my matrix of cofactors is what? Is what? 2. That means my matrix of cofactors is, okay, let me try and leave more space for that. My matrix of cofactors is 2 minus 5 minus 4, 1. This is my matrix of cofactors. So the adjoint of B is the transpose of this matrix. Adjoint of B, which is written as B adjoint, is the transpose of the matrix of cofactors of B. How do I get the transpose? I'll change first row to first column. So 2 minus 5 will become 2 minus 5 here. Change second row to second column. Minus 4, 1 will become minus 4, 1 here. And that gives me my adjoint. So my adjoint is, what's my adjoint? My adjoint of B is what? 2 minus 4 minus 5, 1. So the adjoint of the matrix B is 2 minus 5 minus 4, 1. So that settles question 2. So you will notice here too that all I needed to do to get my adjoint, the matrix itself was what? What was the matrix itself? 1, 4, 5, 2. You will notice also that what? Notice also that B was 1, 4, 5, 2. And B transpose, adjoint of B was what? Adjoint of B is now 2 minus 4 minus 5, 1. So essentially, all that we've done to get the adjoint of this matrix is to just swap the elements in this diagonal from 1, 2 to 2, 1. I hope you can see that. After doing that, we just multiply 4 by minus, 5 by minus, or whatever element is in this second diagonal. We multiply each one by minus 1 to get the adjoint. So the rest should be easy. I'm not going to go through the elementary steps again. I'm just going to use my shortcut. So let's go ahead and find the transpose. Let's go ahead and find the transpose of matrix. Matrix what? In question 3. Matrix C, 3, 4, 6, 5. Matrix C is what? 3, 4, 6, 5. So let me use my shortcut. Adjoint of C is what? The adjoint of matrix C, which is written as Adj C, is 5, 3, minus 4, minus 6. It's as simple as that. So I just use my shortcut. You understand? Swap 3 and 5, then multiply this by minus and this by minus. That's all to get my adjoint. So I gave 5 questions in the example. As your exercise, you do questions 4 and 5 and submit in your comment section.